Hello and welcome to the last video on jewelry cam instructions. In this video we will cover the auxiliary functions of jewelry cam, and all of these functions are to be found under the jewelry cam toolbar. Even though this is the last lesson and these are indeed additional functions rather than the main ones, they're worthwhile learning about as they are shortcuts for common operations. And as you learn and progress with your jewelry cam experience, you'll find them very, very useful. So for this test, I'm going to use this pattern and this geometry with various symmetries, both symmetrical across this horizontal axis as well as some polar axis symmetry. And I will use this strange looking object to show you how these various functions, auxiliary functions, can come in very handy when milling out an object that has some sort of repetition. So, as you recall, one of our first steps in cutting out any geometry is to create a cut that removes the excess stock. And we do that by drawing some sort of a curve that goes around and trims away potential any excess of wax that we might have. So here we can begin to use one of our first auxiliary buttons. We draw our little curve, and instead of going to new operations and selecting things, we can just press this button, cut and curves, and press enter, and our cut and curve operation is already automatically added for us. As long as we are happy with the depth of our curve and whatever other parameters we might have, this is our curve and one button click. Another button click will create a mirrored operation for you, so now we could have this cut from both sides. Beyond that, let's see what we have. Let's say we want to mill out this whole disk, but instead of specifying this whole area and letting the bit travel as it would across, we're going to try to be a little bit more clever about and segment it. So we're going to take this one slice of spy, and we're going to use the second auxiliary button, which is the boundary curve or parallel cuts, and we're going to right click on it. And we're right clicking it because we already have a curve selected. Left click would allow us to create a curve and then automatically select it. In this case, we just need to right click it, and we could either choose to calculate the toolpath or not. In this case, I'm going to choose to calculate it, and there we go. So once again, one button click with a selected boundary curve has added the parallel cuts for us, parallel cuts operation, and has calculated for us. So now that we have this little piece of the pie, we can proceed to calculate other similar areas. For example, if you divide this circle into two halves, you will notice that this part is the mirror image of this part. So one of the auxiliary functions that we have, it looks like these two sides of a circle, is to duplicate and mirror a toolpath. We can also optionally just mirror the toolpath, but in this case, we don't want to change the boundary curve from here to here. We actually want to create a new toolpath based on this little slice. So I'm gonna have this toolpath selected in the operation list and click on duplicate and mirror. It's going to ask for my start of the mirror plane as usual. I'm going to specify cut across, and you'll see that a new toolpath has appeared. Click on calculate, and notice here that jewelry cam didn't outright copy the toolpath lines here. Otherwise, as you imagine, you would see this test in a different fashion. it simply copied the boundary curve as well as its parameters. So obviously the side of cutting, the step over size, etc., orientation. So if there's slightly different geometry here, so for example another ornament, it would still be calculated correctly. It would not be just blindingly copying this to this. It's trying to be quite clever about it. Now, let's say we want to take the same segment, this closed boundary curve, and now rotate it and create a new toolpath based on that. We can do that too. To do that, we use our duplicate and rotate function, and once again a toolpath rather than just boundary curve should be selected in this window, and we click on duplicate and rotate. We'll specify our beginning of rotation axis and in the rotation axis somewhere. We'll specify our first point as here, sort of the end of the boundary curve, and beginning is going to be here. So just moving it right adjacent next to it. And we can see now we have this next step of the toolpath copied over. For convenience sake, let's also copy over this boundary curve too. Oops. Select the center. Select our point to move, and there we are. And now we see that the stool path, even though it had no boundary curve here before, it fits exactly within that same segment. And even though the geometry underneath it is a little bit different, it's certainly different from this, there's no text and there's this additional little bump, it still has calculated correctly. We can continue to use these principles of mirroring and copying to fill out the circle without having to do a lot of manual work. Let me show you that, some more examples of that. So now let's use duplicate and mirror again. Select our center of the circle and mirror it over. There's our left side again. And we can copy our toolpath and rotate it one more time. And here we will once again select just turn off the center snap for a second. Go from here to here. Looks like I overshot it a little bit, so we're missing a segment here. So let's do that one more time and create that another toolpath. Something like that. Oh, we got a bit of an overlap. I didn't quite get that angle correct. But nonetheless, you get the idea. So now all of these things can be mirrored over and calculated, and segment by segment we can fill out our whole circle in these parts. And as we do all of this, Jewelry Cam continues to simply copy the parameters and boundaries rather than um, following the same toolpaths as we see above. Same principle can apply here. Just need to mirror it across from here. Calculate. There. And can mirror this right away over to the other side. There. And one more time. Alright, and one last time. There is our whole funky looking circle with some extra overlaps with just mirroring and rotation. There is one more auxiliary button that you might find useful, and that's duplicate and move, or just move toolpath. And to demonstrate that, let me just hide all of these guys for a moment. It operates much the same way, simply just on the move operation. So select your or create your boundary toolpath. Let's say it's going to be this little ellipse. We're gonna do parallel cuts the usual way. Of course, we could have gone to the buttons here too. Now we calculate it, so we have our little segment cut out. And as long as we have this selected in the operations, choose duplicate and move, point to move from. Let's go from a center point and move it somewhere around here. And calculate. And there it is. So it's able to move that boundary and the parameters and transform over. This saves you drawing a lot of boundaries. It also saves you from clicking the buttons over and over and making sure that the parameters are the same. They will stay the same when they're duplicated. And overall, it accelerates your workflow when doing repetitive or symmetric designs. One last thing that remains to be mentioned is that there's an additional tab on the toolbar called Machine Parts, and this is quite handy for viewing some components of your machinery, whether for scale or for collision checks. So for example, if you're owner of a Mirror 3, you can load it by clicking the left button and show it by clicking the right button. So in this case, it's kind of showing it a little bit too close to the milling bit, but nonetheless, it gives you an idea of the scale of the whole thing. And if when you're done viewing it, you can hide it. Likewise, you can show or hide holders, such as this one, your cylindrical stock holder. You can show or hide your flat stock holder. And another flat stock holder, as well as a few others. So these can be handy, especially if you're wanting to make sure that you're not colliding with something. if you want to make sure that your wax stock is indeed positioned correctly, or perhaps of another reason that could be useful is checking for ability of the mill bit to reach certain places. So that would be best to do that before you select anything or before you actually perform any operations. So let me just clear that for a second. And let's say, for example, if you had an elaborate model and you weren't sure if you were able to reach it under certain angles. Well, this is your mill to scale. Here you can rotate and move around your model all you want and see how it would look in real life as if you were trying to make it fit this particular thing or make it mill this particular thing. And you can see where collisions might happen, how far it can reach, and all sorts of other useful things of that nature. Hope you enjoyed these videos, and good luck with your milling.